All right, I believe we are live. Welcome everyone to another GameDev stream. I'm Charles, this is Infallible Code, and I'm joined today again by Jason Story, who is pretty much, you are Infallible Code now, because people are starting to email me and say, hey Jason, can you help me with this problem?
So don't worry, I get emails that say Charles, so we're even.
We're even, right? we joke about Jason slowly taking over the Discord channel. So anyway, thank you all for joining us today. Before we get into it, basically what we're going to do is Jason's going to walk us through his approach to creating projects in Unity. And we made a point to call this video Advanced Project Setup because a lot of the things that you're going to see are advanced. So there are definitely things that you may find that you don't understand right away, and that's totally cool. We're going to be here in the chat. I'm going to be watching the chat so we can answer any questions you have. And of course, what we always like to do with these streams is follow up with a dedicated video if there's something more that we'd like you guys would like to see explored. So before we get into that, though, just want to remind everyone, hit that like button. It really, really, really does help the channel. It's a meme at this point. If you're a YouTuber, you have to say all this. Hit the like button, subscribe, but the algorithm. So please do that if you're enjoying the content. Serves two purposes: helps the algorithm, also helps us know that you like what we're doing here, and also drop a comment in the comment section as well if you have anything to say. So where's Barles? Hey, Urizer. Oh, 01. I see a lot of folks here in the chat that I recognize. Thank you all for coming out. Barles, he couldn't make it today. I think he's down at the pool, so maybe in the next stream we'll bring him up. All right, so Jason, without further ado, I know you've got some disclaimers you'd like to throw out.
Yeah. So I'll start by saying, just be warned, there's a good chance of technical difficulties. I'm currently having both computer and internet problems. So
fun stuff.
This might drop out. The camera might drop out. I may end up disappearing. Just keep that in mind. But the main thing is, I really want to highlight this isn't a tutorial. Mm-hmm. We're not really trying to explain the topics or kind of go over them. I've just had a lot of people ask me, how do I work in Unity? And whenever I describe it kind of vaguely, people are like, that's weird, I don't get it. So I thought we'll do a dedicated stream and I'll show it. So this is what I'd call a demonstration and not a tutorial. So there's a lot of stuff here that quite frankly comes from 10 years of doing this. So some of it just might be a little bit confusing, and we'll do our best to cover it as we go. And we'll see how far we get along. I've done here's one I prepared earlier to jump to if we don't really get as far as I'd like. Well, yeah, other than that, as Charles said, it's advanced. So we'll jump in.
Yeah.
Oh, and yeah, different microphone too, by the way. That's also part of the technical difficulties. That's why my voice might sound different.
Someone says, real quick, I am just joining. Can you remind for the new guys who are joining what the topic is of this live stream? Wow. We just covered it. It's going to be an advanced project setup, and we're about to dive in right now. So I think this is a great opportunity to switch over to the desktop view. Let me make sure that's been done. Yep. All right. I think we're good. Why don't you take it away?
Right. So I'm just going to start making a few notes here, and we'll sort of describe this before we do it, because it'll be easier if you understand what the goal was before I actually get to the code. So we're going to start as if we were giving ourselves, or someone else gave us, a requirement or something like a game mechanic we want to implement. And the example I chose was if you take, say, BioShock or Borderlands, and they've got that vending machine where you open it up and there's a list of products and you can pick one and then you can buy it and whatever. I think that's sufficiently complicated, but not too complicated. So that's something that I went with. So if we say it's a vending machine, we have to ask ourselves, what are the requirements for this? And effectively, we can kind of go through some of the obvious ones. So you can open and close it, and then you can see list of products, and then you can buy products or purchase them, and you have a wallet, and it will subtract cost, and maybe we'll say it will add item to your inventory. So these are the requirements as if someone gave them to you, right? And so the next step you kind of want to do is you want to inspect that idea and figure out what business rules I like to go by. But effectively, we're talking about what mechanics are in there. And the way I tend to approach that is from a use case or user story angle. So I would describe what would happen in a certain scenario. So for example, if I see a list of products and I click purchase, but I haven't actually selected anything, I would get a warning to tell me that I haven't selected anything and I should. Likewise, if I see a list of products and I try to purchase it and I can't afford it, then I will get a warning, can't afford it. So these are not massively complicated concepts yet. This is just basically saying this is what someone might give you, and it might always translate one-to-one to like requirements in a game or kind of logic or an algorithm that you'd implement. So going through it and just saying, in the case where X, Y happens. So you can probably guess the rest, right? You get the idea. Try to buy it. If I buy it, it goes into my inventory and money subtracted from my wallet and is removed from the store. And then in various cases, I can't afford it, I get warnings. If I can't afford it, and so on. So that's like the fundamentals of how it works. Now, the first thing I want to pause at here, this stuff here is our sort of checklist to know we succeeded. If it does this stuff, our vending machine works. Now, that may sound obvious, but here's the thing. Nothing in there says anything about Unity or any implementation for databases or anything else. If it does this, our vending machine works. And everything else is literally in implementation detail. And we'll go into more detail what that literally means. But when I talk about implementation details, that's what I mean. Does the rules of your system work regardless of what it's connected to on either end, or how it looks, or how it draws, or what animations you run, or whatever? How do you know the actual system that you've built works? So that's the goal. That's the system that we want to make. And I will jump to the code that I wrote to make it work. Now, this isn't a test of or an example of UIs, so excuse my horrendous user interface example. That's not the point at all.
Programmer UI.
Yeah, pretty much.
While he brings that up, so a topic that he mentioned was, your business rules. And if you've ever come from, software development, that's not related to game development, you'll be familiar with business rules. And in game development, that's basically your game mechanics. And it's just those fundamental aspects of your game or your software that have to be in working order. And typically when you write unit tests, a lot of people tend to be overwhelmed because they think, I got to test all of these things, my whole game. You really want to test your business rules first.
It's kind of another question. Someone says, what do you actually use for this? Obviously, I don't just write a bunch of random, badly spelt, bad grammar sentences into a notepad. Usually, I would use something like Trello if I'm using an actual agile board style project management tool. There's other ones like Hack and Plan, and depending on your project, if it's big enough, you might use something like Jira.
Yeah,
I don't want to get into that angle though, because we could spend ages on ticketing systems.
That's a dedicated video right there. Tools to track your workflow. But
the only reason I said any of that stuff earlier is I really want you to get a sense of what does this do. Like if you didn't see it and I described it to you, you kind of get the idea of what the rules of vending machine are. How purchase it, open and close, can make purchase, blah blah blah. So we'll now get to just the little visuals portion of it. And I might have to, here we go. So this is the idea of your game. You'd open up a shop. You'd have a bunch of products in your shop. If you try to purchase one, I just picked a lot of animals. I've got different, I'll get to that in a second. I've got a lot of different categories. So I tried to purchase something and I get a warning, it's nothing selected. If I click on one and I purchase it. And it says here, I've got a new balance and my balance subtracts. You can see that, subtract balance. Fairly straightforward in terms of what it actually does. And if we want to look at it from a data perspective, here is the vending machine object. And you'll see here, I've got an inventory of the items. I've got a customer. They have a starting balance and products. And then as I buy stuff, products will get added to my inventory. And if I stop it running, you'll see the items are still there, persists, because I'm using scriptable objects in this case. So the first thing I want to say before I go any further is very clearly this is Unity, right? That sounds obvious, but what I mean is it's using Unity UI and it's using scriptable objects. So two very fundamentally Unity-based systems. So you'd be very inclined to think, okay, if I'm building this, I need to build it in Unity. And to kind of go back to that general idea of this note stuff, what I often see happens as the next step after here that people go to is they say, okay, well, I know I need a vending machine. So let's go down here and I'll need an inventory. I'll need a wallet. I'll need maybe a UI, and I, might need whatever. And they kind of go, okay, well, if I need an inventory, that's going to be scriptable objects. And then if I need a UI, that's going to be Unity UI. And they sort of think and build the system from the perspective of what technologies are going to make up the system that I'm using. And that's a problem. And again, we'll get to that in a second why. So this is the basic idea. And next, I just want to show a couple of components of this. So one should be obvious. You should be able to change data without changing anything else, because it's a different concern. So if I go to inventory items here, I can go to furniture, for example, run this, and shop, table, chair, lamp, ottoman, whatever. Same idea, just different items. Because at the end of the day, the inventory is a different concept from the storefront, just handed items to display.
It's an expensive desk, man.
It's a good desk.
It's a good desk. It's a standing desk, right?
So next up, I have a kind of question to the audience.
Ooh.
If you wanted to implement icons, so little icons that display beside each of these characters, who owns that? Where does that data go? Now, I'm going to presume everybody's answering, but the idea I'll give is that most people think that's a data object, that you would put a string or you put some ID or some name representing that information into the data. But if you see the data, this is literally the data for an item. In this case, chicken, name, price, ID. That's all there is as far as I'm concerned for data. And as far as I'm concerned, icons are a representation of the visuals of that object. And it's actually got nothing to do with the item. Because if you think about it, changing the icon shouldn't change the data, right? You shouldn't this is sword 5 that has whatever settings and stats. You could decide to do an entire pass of art and change every icon, and you shouldn't have to update all of your data for your objects, right? And so that's the fundamental difference between something what's called a model and a view model. So you traditionally have a model, which is your data, and a view model, which takes that model, adds some visual stuff to it, and shows it. And to give an example of this, if I go to the vending machine, the view portion of it, so this is the UI here. So this is the UI. I have an icons section here, and if I drop in icon style 1, I get a bunch of icons. And it's irrelevant. I just picked a bunch of random icons. That's not the point. We're not going to get into visuals here. My point is that I made a UI decision to change the visual representation of my product, and it doesn't affect my data, right? They're completely separate concepts. And again, I could pick a different style. I could go vastly different and say, we're doing a different pass.
Ooh, those are cool.
Icons. Yeah, they're part of one of the Humble Bundle packs. I just picked literally the first icons I could find in my store. And of course, obviously the general logic and rules still apply. You can still purchase stuff. And if you eventually hit a point where you run out of money, it should tell me I can't afford it. So warning, can't afford, right? So that's your fundamentals of how this works. Right. With all that said, we're going to start looking at the code now. And I'm going to try to be very careful how I describe and explain this. So what I want to say here first is we describe the business rules we wanted, the logic of a vending machine, validate that so you have a list of items, you make sure the items get visually displayed, you make sure that the items can be selected, you validate that the selection is valid, you have a wallet, you validate they have enough money in the wallet, you validate that they can afford it. There's a lot of logic and business and rules to that. And then there's all the visual stuff. So my question is now, when I go through it, how much of the logic of this application exists in here, and how much is the visuals and the data and whatever? So I have a few examples of this. So if I do a little search here, and I say, let's look at all the scripts in the project. So these are all of the scripts that are in this project at the moment, and most of it is predominantly Dween, and I'm using Odin Inspector to draw those nice little nested inspectors, so I don't have to keep going back to the scriptable objects to show you. But if I say, let's go with these are all the scripts I wrote. So these are the scripts in the project which I have written. And as you can see, there's not that many. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 scripts. Now, if we take these 9 scripts and see which ones of these are UI based, 5 of them are UI. So of the 9 scripts in this project, 5 are UI. And if we have a look at these, they're not going to be that big. So the UI for the wallet literally takes in a wallet, draws the label. In this case, it's not very fancy. It's literally just a number. The UI for the user takes in a user, draws it. In this case, it's just a label, displays it at the top. But you can see how, having been given a user, you could do whatever you like. You could go and grab their gravatar icon. You could, spin a rotating version of the character. It's irrelevant. The point is, this is a display component for a user. And this isn't about UI. I don't want to get too lost here. I just want to point out that, well, there is 5 scripts. It's not really 5 scripts worth of data. This is an item panel that basically handles the, I'd probably even open this one actually just to give you a better sense. There's a lot going on here, but again, I don't want you to focus too much on it. All that really matters is this initialize at the top, which basically says the UI panel receives an enumeration of items, and then what to do when one's selected and what to do when one's deselected. And pretty much everything's irrelevant, right? Because you've got a panel of items. Here is your items to draw, show them, and tell me what happens. And then an individual item basically just receives the item data, and it displays a reference to the panel so that it can toggle itself selected on or off, and then on click, it selects itself. That's all it does. There's not really anything fancy here either. So again, I'm really skipping through these because these aren't relevant. And this is the action panel. That's just the purchase button. And it's just a list of panels. So why all of that? Well, last part of the UI is if I go to the shop, this is the shop. So the shop is the canvas to show and hide, the icon list to display if you want to display icons, and then the 3 other UI components to delegate to. So the shop will basically delegate to those other components. You know, I don't get into that script because we'll get into the nightmare of that. All I'll say is the UI literally draws UI stuff, doesn't do anything else. And if we have a look at the contract for it, you'll actually see it's not that complicated. So this is the entire code for the UI. It's effectively, can you show yourself? Can you hide yourself? Can you receive a collection of items? Can you receive a user a wallet? And can you give me a selected object? Can you set the vending machine that you're currently attached to? Can you show a warning? And can you do some visual display that purchase is completed? And providing you conform to these rules, you're a UI for a vending machine. And I don't really care what you do beyond that point, which will become more important later. So now that we've established that all of the scripts, if we go way back here and we go type script and we say label is UI, if they're all UI and the last category would be, we'll say data, these 3 scripts are data. This is a scriptable object that handles a customer data, which is literally just the items the customer receives and the balance and the wallet. That's all it is. Oh, and the username. And this is the inventory of list of items. That's all it is. And this is a list of icons. That's all that is. And if you see the data, they're literally just tied one-to-one to these components. Just list of items, wallet, list of items for inventory. Icons is just list of icons. So these are very slimline scripts, right? They're exclusive purposes. Some of them are UI. Some of them are for data. Now, after all of that, we get to the reason I'm going in laborious detail through all of these. So if I go back to script again, and I show you all of these that are mine. Again, all of these scripts, we've established these are data, these are UI. So where's all the logic? Where exactly is the vending machine? Well, there's one script, vending machine behavior, and it's right here. And before we go into it, I just want to show you what the contract for this one is, which is hand me a UI to use, hand me an inventory to display, hand me the customer who's using this vending machine. And that's it. And let's have a look at the code that runs that. So the code for the vending machine is on awake, create a vending machine, give it the inventory, give it the UI. When someone calls open, open it. When someone calls close, close it. We're done. Right? That's a vending machine. Now, that's, so this is, I have a hard time figuring out how to transition from here. So I've now shown you the vending machine works in Unity as a UI vending machine that uses all of the Unity stuff. Why do I keep saying it uses Unity stuff? Well, let me show you one other thing before I get into the complexity of code here. This is a separate project. So just to really hammer that home, this is u.vme. Now that's vending machine example. This is the project that we're currently looking at. This is the actual Unity project with all of the Unity assets that we literally are looking at right now. This is a separate class library project outside of Unity. And if I run it, what I've got here, it runs, be nice. If I press question mark, it gives me a list of commands. Help, quit, balance, list, purchase, and select. Well, what if I write, can I? Yes, I can, thankfully. So let me just clear this out. And if I say list, here's a list of products. Coffee, hot chocolate, small scone. And what if I wanted to select one of them? Which one I want to select? Well, I'll select 2. That's the hot chocolate. And I can purchase it. So I purchased it. I spent a certain amount. I can clear that. And I can show my balance. And I have 28 in my wallet. So this is that vending machine running in a console without Unity. It's just a separate thing, whatever else.
Same vending machine, though.
That's the point. It's exactly the same vending machine code. It is not a different project. I didn't duplicate it. I am running the vending machine. I am just not running it in Unity. And just to really hammer that last bit home, let's have a quick look at 2 lines of code. So if I go to the application, and we'll go to the vending machine application, see where's a good place to spot this. Actually, we'll do the console endpoint. It'll probably be clearer here. So here's the app, yeah. So we'll close him, close others. So this is the vending machine in the console application. Create a vending machine, give it a simple inventory, give it a console view, and it'll do stuff with that.
Which that line right there is pretty much exactly what you called in Unity, except you pass in your Unity version of the view and the inventory.
So in this case, the simple customer is just a name. The simple inventory is just 3 products. And then the console view, that gets a bit more complicated. It's effectively a text-based vending machine view, which uses the console for input and output. But all I want you to focus on, see this line here. Vending machine is new vending machine, simple inventory, console view. Let's bring back up Unity. Vending machine equals new vending machine, inventory, in view. So clearly, I've managed to take the concept of vending machine, and it's irrelevant to whether it's running in Unity or not. And this is kind of what we were saying about the differences between Unity as a rendering engine versus Unity as like your game engine. So we'll pause there for a second, because I imagine that's very complicated stuff. And we'll actually start doing some of this. You'll start to see what I mean in more detail.
Yeah.
But I just want to pause there just to demonstrate that in here, all the vending machine stuff is outside of Unity. It is a vending machine application which does vending machine related stuff and doesn't know Unity even exists. In fact, so much so, if I run my unit tests for it, not only can I ensure that it works outside of Unity, I can validate every possible thing that it can do. I can say, when purchase complete, remove the item from the vending machine inventory. When purchase complete, remove the price from the person's wallet. When purchasing but can't afford it, warn the UI. What does warning the UI look like? I don't know. Does it shake things? Does it give me an exclamation mark warning? Does it write a console line? I don't care. What matters is, when I use a vending machine and I can't purchase it, the UI should get warned that that event has occurred. And this sounds like it might be like, if you're isolating into 3 different parts, you've got the vending machine code and the Unity code and the console. Surely this has got to be really complicated, right? Well, we can have a quick look. Let's have a look at what the vending machine logic looks like, or the vending machine tests first, because that'll kind of give you a better example. So these are my tests for the vending machine. Let's take one of the more complex ones. Oh yeah, like when purchasing a product, give the item to the customer. Well, we have a customer. The wallet is a wallet with balance 20. We create an item with a price of 5. We tell the view that it's returning a selected item, which is that one. So for example, we're saying, whatever the UI is, it has currently selected this item with a price of 5. What item? I don't care. All I care about right now is the price. I open the vending machine, I make a purchase, and did the customer receive the item that it asked for? And likewise with other stuff down here. Let's pick another one that kind of explains something in detail. Want to find interesting ones, because a lot of these are plumbing stuff that when can't afford. Here we go. So the wallet is a wallet with balance of 5. The UI is telling me that it's an item with a price of 10. I open it, I make a purchase, and the UI received a warning, cannot afford. So you can see how I can still do all of the rules, all of the logic, all of the validation, and I can ensure it works without ever even looking at Unity. So I would actually normally work like this. I would write the entire thing. It would work here. I would drop into Unity, and I'll explain how I do that in a second. And then I would just hook up UI to it. And so all of a sudden, I know my UI is just going to be showing the stuff that's running here, and I don't have to go dig around in Unity to verify that it works. And this, sorry, go ahead. I thought you were going to say something.
Sorry, I was just taking a sip of my drink.
Okay, well, so basically the benefit to this for me is if you ever worked in VR, for example, and you've got a big VR project, it can be a bit of a pain in the ass to test a system where you have to load the game, put on the VR headset, navigate to that point in the level, press the button on the inventory thing, open it, perform a purchase, maybe give yourself some command line tool to give yourself the right amount or less amount of money, test it, check that it works, close it, change the line of code, repeat the cycle.
Go back, yeah.
Here, I can write a test that it works, and also I don't have to deal with regressions, because if I add a test and I'm worried I broke something else, I have this automatically running because I'm using Writer Ultimate, which is one of the features. If I just actually save, you can't see it here, but it's actually rerunning all of my tests. So literally just the act of writing a line of code and pressing save, it reruns all the code, all the tests I have existing in the project. So in real time, I'd actually have the test window open on a separate monitor, and I would just be working, and I would be seeing things turn red if stuff breaks real time as I write my code. So
We got a couple
that
comments just to bring up real
yeah,
quick.
that's a good point to pause at. So yeah, fire away.
Yeah. So Groverko mentions, so basically you're using Unity only as a renderer. And yes, and that's something you brought up earlier, and just want to drive the point home. And we started this talking about business rules and what that means, and how we kind of relate that to game mechanics. But realistically, you should be able to work on your business rules, your game mechanics, apart from the actual rendering. And then the example you just brought up was a great one in VR development. You don't want to have to put your headset on every single time you make code change.
I've been there, man. I've done VR projects during game jams, and half of my time was panicked trying to make sure that I'm repeating the cycle of testing stuff fast enough with the headset. It's just a nightmare.
Yeah. Another question was, is this N substitute? I think this is fluent assertions you're using, right? For your tests?
So I'm using a combination of NUnit for my testing, and then I'm using fluent assertions for the assertion syntax, and then N substitute for my substitutes, which if I go back to the top here, I create a substitute for the customer because I don't actually care right this moment. Substitute for the inventory, substitute for the UI, because what I'm testing in this moment is the vending machine. So the vending machine should work regardless of what the UI is, regardless of what the inventory is, regardless of everything else. And I guess that's a good point to highlight again, because I said this way at the start, and I said to remember this. I didn't once ask myself, am I making this using scriptable objects? Am I making this using Unity UI, or do I want to use a new Unity UI? Because that shouldn't make any bearing on the logic of my vending machine. It either works or it doesn't if it conforms to the rules we wrote down, and then those decisions come afterwards. So by definition, I'm substituting in those things, and I fake what they come back with. So that's, if you've never used N substitute before, that's what this stuff is. That's how I could say, here's a fake customer with a wallet. That wallet's going to return a wallet with a balance of 5. So I don't care what the details of where that wallet comes from. Am I loading a web API? Am I validating the user by logging into a web service? That may come later, but that doesn't affect whether or not a vending machine works. Likewise with products, am I loading the selected item? Am I selecting it by clicking on it? Am I selecting it because I've opened something and it's the first item there? Is it selecting it because I'm using a voice control menu and it's selecting the first thing that I say? It doesn't matter. What matters is, does it select the thing, yes or no? And same with the items. Whenever I build something where I'm testing items, let's see, probably an example of one here somewhere. Here we go. I have the inventory. So I create 3 items, and then I set the inventory items, and then I test that inventory. And if I show you this, it's exactly the same idea. The inventory's items returns these items. Are they stored in the database? Are they a text file? Is that text file a flat file? Is it a JSON file? It doesn't matter. And so when a lot of people ask questions like, should I save to this, or should I use JSON, or should I whatever? It's irrelevant. Right now, your problem is due a vending machine. So it doesn't matter I will decide later what I want relative to the concerns of the project. Right. And I shouldn't have to change a single line about my vending machine because I've decided I want to change from using XML to JSON or vice versa.
And that's kind of the point here. The point isn't with, when bringing up N substitute and this, it's not that N substitute is a great framework for mocking. It's the fact that Jason's written his code in a way that he can mock things because it's so separated, and the concerns are strictly, hey, I've got this inventory and it has its set of logic. I've got the concept of an item and it has its set of business rules, a wallet. We're not wrapped up in, okay, is this a scriptable object? How do you couldn't mock a scriptable object? Is it a game object? Do I need to add component? No, all that is a completely separate concern, which is rendering. And so because of that, now we can leverage things like N substitute, and we can write tests that are much easier to maintain.
And one valid concern is that's a lot of plumbing and stuff in advance. Would it not be better to make a prototype? Yeah, and this is where I'll draw a line and say that I've said this before. There's 2 kinds of systems. There's loop-driven and event-driven. So loop-driven is your game loop. It's like literally moving around, calculating movement, calculating physics ticks. You can unit test those, and you could even isolate them out. There's actually ways to use exactly this strategy for the same thing. But I'll be honest, even I don't do that because that's a lot of labor for what comes down to game feel. And game feel is exactly that. I want a prototype for character jumping up and down on a box. I'll drop in a character controller. I'll drop in a box. You don't need to do this. This is for event-based systems. And the event-based system in this case is the interacting process of using a vending machine. And realistically, I don't need a prototype that my vending machine exists, because what am I going to test? That it's fun to use or that it's mechanically proficient? I mean, if I've decided I want a vending machine, and it conforms to the rules of the vending machine, I don't really care about prototyping tests that like the boxes look nice or that it feels good to click on, because that's not my job. That's not my concern. And realistically, if a project is big enough, you would have someone doing that. You'd have someone prototyping UI separate from you. And the fact that you have to write the rules that at some stage say person of hunter class can't use the warrior weapons or can't buy them, or the items don't show up in the store if they belong to the class that's not you're not part of, or maybe it's a special item of the day, and if it's this time of day and you haven't bought this thing, display it. All of that kind of like really obtuse and specific logic has nothing to do with prototyping or testing it in Unity, right? Like someone could prototype that visually. Someone could put a rectangle Pro Builder and put some buttons on it to prototype it mechanically. But as far as like getting the code written and done, if that's your job, you don't need any of that prototyping, right? So line drawn, if you're doing character stuff, gameplay stuff, sometimes it makes sense. But realistically, a lot of your systems aren't that. If I have a cool system where I'm swapping out different guns, the guns can be prototyped as mechanically, which are fun in game, but the concept of an inventory that receives guns and swaps them, and the fact that a gun has to reload, and if it's run out of charge, you have to wait a certain amount of time and it recharges. You can test the numbers, prototype stuff in Unity, but when you're writing code to validate that it works and that you can switch weapons and that you can't equip two of the same weapon, and certain weapons, if you already have it, will give you ammo, but the ammo won't go past a certain amount, you don't need to run around and test that. You can literally press button and check the numbers match, you know?
Yeah. Oh, I guess one last question that was brought up was, are you going to make this project available?
Unfortunately, I can't, given how much assets and stuff are not mine in this. But hopefully what we'll do is, once we're finished describing this, which we're pretty much done with now, we'll start setting up a project like this. And I'll start going through some of the basics. And hopefully it'll give you enough grounding that you could basically start having a look at this yourself. So we're going to do that in a second. I'm just going to basically start as if I was making a new project, and I'll just show you what my general process to get this like layering done.
Here, I'll be your boss. Jason, we need a vending machine. We need it yesterday.
Yes, sir. Right. Let's give a start on that. So, just want to make sure is everyone comfortable up till now as to, because again, this is me showing you like this is the end result of it being done, lots of systems and whatever. So don't expect to have understood all of this or why I did it, or a lot of it may seem overkill or unnecessary.
Yeah.
But all I'm demonstrating is that, as you can see, there's a very clear benefit and a reason why I did it. Now, it's a judgment call as to when and why, and you might have a different understanding or requirements than I do. But it's very hard to say this doesn't very clearly add a lot of value for someone in my position, where I can test the entire thing as a console application. I can test all of my stuff, and I don't even need to go near Unity and deal with builds and all this kind of stuff. And also, as a small side note, which we'll demonstrate in a second, if I change this file while Unity's open, it will automatically update in Unity. I don't have to build this, take a DLL, drag anything in, and I'll show you that in a second. But the fact is, none of this is actually separate from Unity in the way you think it is. And just as one quick example of this, let's take, I guess character would be a good example. So let's take the character, or user. So we've got name and class. Let's give the user a level. So I've added the concept of level to my vending machine project here,
wow,
right?
I've never seen like a clash of worlds like this. You know, a user, you think it'd be like a character, like the player who would have a level, but it's like the user has a level. Like as someone who comes from the business world, I'm like, what? This is so weird.
So we've added level to this, and I haven't gone near Unity yet. If I go over to this Unity version of the project, and I'm in this UI stuff here, if I say, do a quick void example, I can say customer.user, and there's my level. So notice I didn't copy anything or move anything or change anything. So it's not like they're completely separate, isolated worlds. Like it's set up so that I can work from one to the other extremely quickly. And not just from this setup. Like if I'm running in this project and I'm like, oh, I want to make changes to that other stuff, I've made a few things to make my life easier for that. So once Unity is caught up, which is again why I like to not work in Unity sometimes. If I go to tools here, I can say Open C# project, and you won't see that because it opens up and then
this is proprietary, by the way. Don't go looking in your Unity
editor. Yeah, it's just a random thing, but basically it means when I click this, it'll open up that project. You can't see it unfortunately because of the whatever. But my point is that will open up that project. And if I show you how that works without going into too much detail, if I go to preferences here, I've got this thing here called project integration. and I say, this is the current Unity directory of this project. So I open that, it's this folder here. And if I go up one and down one, that's the relative position of the external project. And that's what this is saying here. Go up one folder from here. And if I can say, like, that's the same folder, that's one folder up, two folders up. And I'm just saying the relative project is one folder up from here. And if I open the directory, that's the other project. And if I click that, that opens that other project, which is the same as the icon button. So effectively, like, there's no lag time in organizing and setting it up. So the question of, like, is it a lot of plumbing and effort? Maybe, but not when you've been doing it as many times as I have, and you've optimized a few of the pain points out of the way.
We've spoken, the benefits to the developer, and there's certainly a lot of benefits to the developer. But when it comes to what's the point, you're making the game, you're trying to get it to a user to play and have them enjoy that. This level of sophistication opens up a whole new world. It opens up a whole new world. And so as a practical example, let's just say you wanted to expose a website where if you're at work and you wanted to, log into the game and like look at your inventory and maybe make some purchases for this particular example, you could certainly take this same vendor project, the same vendor class, vending machine, and we can expose that on an API, for instance, and none of the underlying baseline game mechanics or business rules would have to change. No additional code would need to be written. The only thing that would be different is I'm exposing this as an API, and I might need to make a web interface. Same for like if you wanted to make a mobile app or something.
Yeah.
And I know
like another thing too is if you're doing to multiple sources. So for example, right now my repository is scriptable objects, which is Unity exclusive. I can't use that in my console application unless I literally include the Unity engine DLL. But I could make versions of that's a repository pattern of an item repository that is a text file item repository, JSON item repository, XML item repository, web service item repository, many different implementations of whatever I want. And because they are not project dependent, I could decide later we're moving away from scriptable objects to a web service, and I would just be able to call one line of code in my Unity project because that's the implementation I have in my console application, and they're not mutually exclusive. Because the idea is the contract says, what do you have to be to qualify to be an inventory? You have to be able to give me items. How does that work? I don't care. Just give me items. And then there's other stuff too when you get into more detail about saving and loading. But realistically, if you say, you know how to save, you know how to load, you know how to add items, you know how to remove items, and you know how to give me the items in the inventory, you've got what's called a repository. And then I don't care whether when I say, give me the last 5 added items or give me today's number 1 chosen item. Do I care if that's running a database query? Do I care if that's a NoSQL database? Do I care if it's loading a file called today's special items? Do I care if it's coming from a ship? I don't care. Like, the point is, the vending machine will work irrespective of what source I have, and I can move those sources kind of like Lego blocks between different projects. So I could have a version of this project that runs in a WinForm, one that runs as WPF, one that runs in Unity, one that runs as a console, and I could have sources of data that come from a test database server, a scriptable object database, flat files, test files, different environment files, and I can just choose whichever, go to whichever, because it doesn't matter, right?
Yeah. Well, I think we've thoroughly convinced anyone watching that this is valuable, hopefully. So let's dive in.
So let's start up real quick, and we'll just go with a new project, and I'm going to call it, I don't know, awesome project. So this is awesome project example, and that's the folder I'm going to work in. And I'm going to try to start this. Now, this will be slower than I would normally do stuff, but I'm going to do it with an educational bent in mind. So don't worry. You'll have to trust me when I say I can actually spin these up pretty fast. So I use the u prefix to denote this is specifically a Unity version of the project, and I'm going to call this AP for awesome project. As for why I do that, well, once you have a lot of projects and you start building a lot of complicated namespaces, you're going to end up with large chains of namespace names. So I often find the root name should be an acronym of whatever the larger thing is. Personal choice. Right, so that's going to take a while. Unity will take a while to build.
They're asking about the project integration thing, and whether or not it was a Unity plugin. That's Jason's plugin.
So literally all that is you can. There's one tag you can write that will let you reference the preferences menu, and then I just have one line of code that says get the directory of this project, and then backstep X number of steps, get that directory, save it to the editor prefs, and then when I click that menu item, call process.start that URL. It's not actually that many lines of code. There's some extra lines in code there to make the nice editor and have it like auto select and all that stuff and like try to guess what folder you probably mean. But at the end of the day, it's like 4 lines of code. You'd be surprised how quick it is to set something like that.
And you don't need it to. It's just a helper.
It's a nice little, like this one won't have it, and we'll add it later just to show you how it's kind of not necessary.
Yeah. It's better to understand what it's doing behind the scenes anyway.
Exactly, yeah. So this is a brand new empty Unity project, and I want to start explaining a few things about DLLs and how code builds before we get any further. So people don't think about this, but Unity doesn't build your scripts. It does build your scripts, but it's not in charge of building your scripts. And it doesn't actually do anything different than your system does, because they both use something called MsBuild. And we're going to demonstrate that now in a second. So if I just pull this to the side. So this is our project. And what I want to do is I want to show you something. So I go into the libraries folder here. This is all the, for lack of a better word, crap that Unity puts into your project. Again, this is not me making fun of Unity. It's just literally like the stuff that's needed to make Unity work. But if I go to script assemblies, here's all of the DLLs that get included in your project. So the collab, writer, TextMesh Pro, whatever. And you can add or remove these from the package manager. But fundamentally, empty project, these are like built into your project. So what we're going to do just to demonstrate a point is we're going to hide these. They're not going away. They're still there. And Unity will rebuild these when it needs to. But we're not caring about those right now. So this folder represents the output of all of the scripts in your Unity project. So let me see what happens when I just write an empty script. New C# script, call it hello world. And I stop, and bang, suddenly a DLL appears. What's that DLL? What's it doing? Well, Unity.
The most boring Pokemon game ever. A wild DLL appears.
Yeah. Well, you caught it whether you wanted it or not. So Unity built this, and it's using assembly-C#. And what this is this is a class library project, just like the ones we saw earlier, but it's the one that Unity built and then built it into this DLL. And so let's have a look at what the DLL looks like. Just take a second.
That's a Unity convention, by the way. By default, if you don't define an assembly, and I have a couple of videos on assemblies in Unity, by default, it will make an assembly called, what is it called again?
Assembly-C#.
Yeah, assembly-C#.
So this is the script. I didn't even do anything yet, right? I literally just saved an empty script to Unity, and it makes it, builds it, runs it, and gives me this thing, and it builds this DLL. So Unity's already doing a lot of just magic the minute I press something. And if I open this, we can actually start to inspect how it does that. So if you've ever worked outside of Unity, you're probably more familiar with this than the Unity version of it, which is, this is literally it's called a project file. So it's like an actual C# project. So if I open this, so I'm in Unity view at the moment, so you see it kind of like a Unity project. But if you go back to solution view, solution is a collection of projects. So in this case, this is a solution, and one of the solutions in it is one called assembly-C#. And that's the one Unity made for us automatically. 1 second. And if we open this, this is just code. This is like what happens. It writes the script, puts it in here. But the way it does the build stuff we just saw is that this actual build file, if I go to edit and look at the CS project file, you'll see it's actually doing a lot of stuff for us. But what it's doing is it's literally saying, let me just zoom in a little bit. It's saying, here's an item group. An item group is just a collection of things. And it's saying, include in this build these DLLs, all of these DLLs, add them to the project, blah, 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 blah. And then when you're finished building, what you want to do is output it to your output path of temp/bin/debug. And then Unity takes the output of that and it moves it into the other place. So we're actually going to edit one of these in a while. It's not going to get too scary, don't worry. But I just want to highlight that this is like, Unity is not acting any different than any other system. So when I make a class library for a console application or for a WinForms application, Unity's doing the same thing I'm doing. It's just doing it for you. And so it's not as strange anymore when I say, I just do this outside of Unity. I just take that one requirement step away from Unity, and I do that myself. So with that in mind, now that we can see Unity is using a MsBuild system to build a CS project into its script assemblies folder, and then at build time, we'll take these and then build it into your actual DLL. We're not going to actually build, we could build an executable to prove it again, but you'll get the point. It'll just move these files and run a slightly different set of preprocessor commands on it. But fundamentally, it just copies this into your build file. So that's your DLL. But here's the first bit of interest. When people wonder what are assembly definitions, well, if I make a folder here and call it, I'll just use stuff. I like using random pointless words. So stuff, drop in this. Now, it'll do a little flicker there. You might have seen, and that basically says, I did a quick rebuild because you've messed with the files. But it didn't do anything different. It's still in this CS proj file. But this is where we talk about what assembly definitions are and why it's a cool addition. And it's sort of like if you use assembly definition, it is like a stopgap between the system that I'm using and sort of a way to get there. So if I create alongside this a assembly definition and I call it stuff, and that's all I do, add an assembly definition, I've done nothing else, all of a sudden, there we go. So now we've got stuff.dll. So what it's done is it says, because this isn't in the global namespace anymore, it's not just a script randomly in your project. And just to prove that, if I go back here and I add another script and call it things, doesn't matter, you'll see this one is back in assembly C# because it lives outside. It's like in the global, the project as a whole. Well, this one is inside a built separate DLL. So this is saying these scripts belong to this isolated concept. And I can't just reference that script into this script because they're not in the same DLL. And that's where we get to what DLL literally stands for, which is dynamically linked library, because they are separate chunks of isolated built together scripts that you can take two separate DLLs and attach them together and say, this one knows about this one. And that's at the crux of it, what DLLs are all about. It's to say, this is a named packet of scripts that doesn't need to know about anything else to do its job, and other things that need to use it take a bunch of DLLs, reference each other, and then do extra work with them. And that's literally what all of the namespace includes at the top are the imports. You're basically saying, import these things into this file, and it'll just magically reference them, and that build file will add that include for you automatically.
I dropped a link in the chat to my my video on assembly definitions for if you want to watch that later to learn a little bit more about what happened there when he put that assembly definition file in place.
Yeah, that'll cover quite nicely like what you were doing when you're messing with assembly definitions and show you how to architect them in a good way.
Right.
So now that you've seen assembly definitions are effectively just a way of building a named DLL separately from the other stuff, it doesn't sound as strange now when I say, I want to go outside of Unity, build a DLL, and drop into this folder. That's all I'm doing. I just don't want to be doing it inside of Unity because, as you can see, every time I make a change here, I have to wait for Unity to see it, realize it, build it, move the thing, change it, hook up whatever needs to be done. So if I have a concept like a vending machine that I know doesn't really need to talk to TextMesh Pro, doesn't need to talk to the timeline, like I can just do it over there. And when I'm done, it'll build and drop into Unity when it's finished. So hopefully that explains what DLLs are and also kind of why they exist separately and can be linked. And I guess one last note as to the actual existence of why they're there, which is whenever you change a script, I think this kind of proves the point again. This is literally rebuilding everything because I change one thing, it rebuilds it. The beauty of using assembly definitions is if I've got scripts in here in this stuff DLL and I decide to make a new script, doesn't matter, Unity just has to rebuild the stuff DLL because it knows for a fact, because of the structure of how DLLs work, nothing else outside of it's changed. And so imagine how much faster that is for all of the different cycles of compiling and building. When you've got like 10 assets in your project, they've all got 100 scripts apiece, and they're all doing crazy stuff. And you've just got this tiny thing with 3 scripts that are meant to deal with vending machines that in the existing system without using assembly definitions, I like added int field to my wallet. All of a sudden, the whole project rebuilds and goes through all the process and makes sure all the scripts are done and rebinds everything and hooks everything up. But with a separate DLL, it'll say, oh, I've changed, and I'll just replace myself, and everyone else already knows how to talk to me because none of the rules have changed between us. And so that's the point of DLLs. And fun little history, why it even exists is because back in the old days when you actually would serve software on floppy disks, and you actually, or even before that, companies used to have to send a technician around and install their software onto the actual terminals of the different companies that they work with. So you can imagine if you made a bug and you had to do an update or a patch, you have to send a team of people to fly around the world to all of the companies and update everything. So how do you avoid doing that? Well, wouldn't it be nice if you could patch your system? Sure, but how do you patch a system? Because if you change a script, all of the connections and rules have changed because like it doesn't know anymore what everything is, has to rebuild it. That's where DLLs came in. Because what DLLs let you do is say, I've split my system up into payments, and this one does talking to our invoicing service, and this one talks to our database for your statistics of what your company's doing. This is your payroll system or whatever. If there's a bug in payroll, they don't have to either send a tech out, and they don't have to send out a giant, like, rebuild the app. It's like when you download a bug fix for a game that's like 6 gigs in size. You can just send out the one DLL that changed. So you can send out, like, you know, a couple of kilobytes of data on a floppy disk or in an email or whatever, as opposed to it'll rebuild the entire app because one bug was fixed in one set of scripts in one little component in one piece. So DLLs let you literally isolate your project, not just from a conceptual, it's nice to have way, but in a literal, the system doesn't need to worry about the interconnected nature of the system. It can rebuild, and there's a term for that called independent deployability. You can deploy parts of the system and just hope the other part works for you. So you've got a team of 10 people working on a project. 3 of them could be working on the vending machine project. 5 of them could be over here working on the payroll system. And you don't have to worry about one talking to the other. Now, theoretically, if one rebuilds, you may have to do different things if the contracts change. But fundamentally, it means it's not your job anymore. You take for granted the payroll system works, and you work with the payroll system. You're not held up by their system. You don't have to wait for everyone to merge together and build it. You just say, look, give me a DLL that does the things that has a contract that I can talk to. And then providing it works, I don't care what your update rate is. You can update and change and patch your system at a completely different rate than the rest of our code, because our code uses it. It doesn't rely on the actual implementation details because that's part of your DLL. All I care about is the contract. And this gets even further into something where you actually have DLL contracts. You have a DLL designed to give a contract. This thing implements that DLL, and this thing uses that interface. And then there's a config file which connects these two together. And that basically means that you can literally deploy these two, and you can actually swap out different implementations. And that's how you get plugins. So without going into a whole different thing about that, that's how applications like Audacity and Visual Studio can literally let you add those VSX files that add plugins, because they're using DLLs. A DLL drops in, loads into memory, checks if it matches the contract, and then dynamically builds at runtime the different things that implement that interface. Because it doesn't actually care where it came from, it cares that it conforms to that DLL contract. So, whole different thing. We're not even going to go near that. It's not relevant. All I want to say is DLLs are not just some random like code thing. There's a very long history of what they're for, why you use them, and the benefits they can give you. And if you kind of get that idea, when I say I want to build a DLL outside of Unity, it stops feeling like I'm doing some weird hack where I'm building a separate project, and it's just like, I'm just building a DLL.
Yeah.
How do I choose to do it? A different way than someone else is doing it. Right?
Yeah, and that's there's 2 things to address here. I saw on the Divians and mentioned every time I watch Jason talk, it makes me feel like I need a degree in computer science. But you know, these things that we're talking about, you know, we have a good understanding of them because of our backgrounds, because we've used them so much. But you know, if you're working in the space of Unity and your goals are to separate your project, increase build times, and to have better architecture, you know, it's doable. You don't need to get a CS degree to be able to use these things effectively as a game developer. And I want to make a point of that, because I know a lot of times the feedback we receive is, oh, this is overkill, this is too much, but really, you know, it's not something that anyone needs to be afraid of. You know, there's plenty of great videos out there, including, shameless plug, my own. And once you use them in your projects, trust me, they're very easy to get the hang of, and I don't want anyone to feel like, oh, this is beyond my I could never use this. Anyone could use this. It's just
like I right at the start, I even wrote it down to make sure I remember to mention it. This is not a tutorial, and you're not meant to pick all of this up. This is a demonstration of the way I approach this after doing this for 10, 12 years. Like, it's not, do not feel like you need to know how to do everything I'm saying here. I'm just doing it to demonstrate kind of where we're going when we're describing this stuff. Like, there's a method to the madness of all of the stuff we're saying.
Yeah.
A lot of people often look at this and say, man, I'm making games, I don't need this stuff. And it's like, that's good for you, but like, let's just say I come from other fields of software. I've done mobile apps and web apps, and I've done stuff with Android. I've done stuff for web services. I've done database backends. I've done full mean stack development. I've done like tons of different things, and all of them have some like little ways of doing things. And you pick a few of them up, and some of them are good for multiple projects. So I'm not saying you have to do all of these things. I'm saying that there are certain things I enjoy the benefits of from different systems or different ways of working, and we are going to talk about them. You can, if you like them, you could use them. Right.
Cool.
So I think that's a huge a huge separate content to go on. So I guess now that we've established the relationship between the two concepts, that this is Unity and that you don't have to work in Unity, we're now going to just minimize this for now, and we're going to come back to that later. So now this is our awesome project example folder, and that's our Unity project. So what we're going to do now is we're going to make a non-Unity project. And so I'm going to say new, and I'm going to make a class library. And for reasons that are not relevant right now, there's two categories. There's .NET Core and .NET Framework. Framework is the older one, but it's also the one that for most tech cases you're probably going to be using. Mm-hmm. So just stick with Framework. And it's not, when I say old, it's not even that old. It's just not the new one. So we'll go to this folder. And so I'm now going to call this, what did I call the other one? AP. So I'm going to call this AP. And I always like to make a Git repo. It's a class library in C#, and everything else is pretty much default. So if I create this, any day. Like I said, I'm having technical problems, which include my computer running slow, so you'll have to bear with me.
It's been pretty good so far.
Good.
I did, knock on wood, I think I just jinxed us.
Yeah, thanks for that. So we've got this AP class project. Yes, all of these automatic pop-ups. So we've got this AP class library in this AP project that exists sort of separately from Unity, right? So now I can just say something, and I'm going to call it wallet. So it's going to make a thing called wallet, and we're going to say, just for simplicity, public int balance. And also probably should name the file to match that. Thank you. And always add, close all of this, go away, stop the pop-ups. So we've got a DLL now called AP. Now if I build this, it finishes building. I can now go to the directory. So just as a reminder, here's our hierarchy structure. This is the project we're in. This is the non-Unity one. This is the Unity one. And just like with the Unity has the script assemblies directory where it pumps out all the DLLs of the building, so does a class library. So I go to AP, bin, debug. That's the thing we just built. And again, you can open that up in .p. In .peek, it'll show you the file. I think, just trust me, it's fine. That's this file built into a DLL. And so that's straightforward. You can just work here now. You can just make stuff, and whenever I wanted to, I could just copy this, head on over to our Unity project, open up this. I like to make a folder called plugins because that's the recommendation from Unity. And then I can just open that plugins directory, paste it in, and click, and Unity will do its rebuild. And
by the way, we're getting some requests to increase the font size. It's harder to do in Unity, unfortunately. So I'm sorry about that. But in when we get back to the code editor, we'll be able to.
Yeah, we will. Yeah. So basically, all I'm doing is I'm literally copying this DLL from this folder here. I'm just copying this DLL, and I'm pasting it in or dragging it into Unity. That's literally all I'm doing. And so by doing that, it drops into this plugins folder. Unity recognizes it as a plugin. It even lets you do stuff like decide what platforms that specific DLL runs in, which gets to some other fun stuff you can do. Like, for example, I can usually have an editor DLL that only runs in the editor, and when it's built, actually doesn't get included in the project. Again, not relevant right now. Whole series of separate stuff. But all I'm saying is that Unity doesn't think it's any different because it knows it's the same thing. It's a DLL. It's just it didn't build it. It's just going to add it to the project in the same way. And just to show the kind of the side effects of that, if I go to, where was I? Library, script assemblies. It's not going to include it here because it doesn't need it in the build, but it will include it in a built version of the project. Anyway, so the bit that I want to get to is now that I've added this DLL, and just as one small recap, it is just a script called wallet inside the AP namespace inside of that AP DLL. That's what it is. It has now been dragged into this project. And if I now go to this things.cs file, I can now write wallet, and it'll automatically import the AP namespace. And I could say wallet.
Be sure to zoom in a little bit.
Oh, yeah, sorry.
No, you're good.
You're going to have to keep reminding me to do that.
I will.
And there's the wallet. And then I can say wallet.balance. So we're not going to do anything with it right now, but the point is Unity is just working with it as if it was a thing that already existed in Unity, just like it would have been built alternatively. There's one caveat up to this point, which is it's a bit of a pain in the ass to go over here, build some stuff, then go back over here, drag the DLL in, wait for Unity to rebuild it, and then try to work with it. So wouldn't it be nice if we could do that automatically? And that's where we're going to revisit that big, complicated CS proj file. So if I open this and go to edit CS proj file, this is a bit smaller. So this is our pretty much empty project, not the Unity one. Notice it's got a couple of includes. It includes system and, oh, yeah, thank you. So it's got a couple of includes here: system core, system data, system XML. This is what you get out of default by a standard CS project, but obviously none of the Unity stuff because it's not a Unity project. But it's the same shape, right? It's just a project file that says it does a bunch of stuff, sets a couple of platform dependency stuff, which is really fun for database configuration and stuff. It does this, bin debug, and then there's some defined constants, which, by the way, this is how assets like TextMesh Pro can have plugins without worrying about errors if it's not in your project. It's a whole different thing. But either way, my point is output path, bin debug, that's where it goes to. And down here is where the includes are. But other than that, it's exactly the same thing. It will build this DLL into this directory, which we've seen. So if I pull this to the side again, and let's just minimize a few things so it's not getting in the way. This is our, how's the plugins one? Here we go. This is our debug directory. And if I was to delete that, literally all this does is builds those files, includes those things, drops this in here. As for a side note, this PDB file is to do with debugging. So what this does is it handles breakpoints for DLLs. So without getting into a whole separate thing, the good and the bad thing of the DLL is we talked about in a previous stream that this actually isn't C# anymore. Once it hits DLL format, it's actually something called IL, or intermediate language. So it's not actually in C#, which means if a bug is thrown, like an exception is thrown inside of a DLL, it can't just point to the line it's in because there's no line anymore. It's actually a series of stepped processes. And yeah, I'll show it briefly just because I think we covered it before, but I'll just recap on what IL is.
Real quick, wanted to thank you, Louis Vaughn, for the super chat. Appreciate it.
And yeah, the question is, if you got a load of code in DLLs, does Unity still take some time to digest those? Well, I mean, at the end of the day, if you've got lots of files, Unity's still going to have to process them. And if you've got lots of separate DLLs and some of them change, then sure it will. But it is faster than not using DLLs. It's like you can't get rid of the build time required to process it. And the reason why is something we covered in a different stream. So if you go back a few streams, we talked about DLLs a while back. But effectively, the point is the version of the DLL you see in the editor allows for those things like if in edit mode, do this or do that. But when it comes to build time, it actually runs a different compile process on it. So it can strip out what are called the preprocessor commands. And that's effectively saying, actually, we covered this in a whole different video. I don't want to go into it again. But just to say, yes, when you're building stuff, it's going to have to redo the DLLs, all of them, for a build for a very specific reason. So let me just pull up this here. So this is our DLL. Oh yeah, that's the one we had in Unity, actually, the other things. Let me just close that one and go to this one. So this is the DLL we have that we just built. It's just got our wallet with the balance in it. And this looks like C#. Well, you'll see here it says decompile. Actually, can I zoom in on this? I can. Nice. Aha, I remember this.
Nice. So I missed it.
So this is the very simple script. But again, this is deceptively looks like C# because it's been recompiled back into C#. But if I go to IL code, this is actually what it's stored as. This is like the instructions. And you can look into what IL is, and it's effectively it's a way to run this code on multiple platforms, and that's why Unity and also just .NET code in general can run on pretty much everything. So it basically boils down to this series of steps, and then these steps are run on a processor. Well, it goes through a whole different process first for just-in-time compiler. I don't want to get into that either. All I want to say is that this isn't C#. And so the reason I mention all of that is you have to like fake it back into Resharp to read it. So if you want to debug this code, you need this file. So when you're copying the DLLs over, if you want to see what line of code through the exception, when you copy it over, you need to include the PDB file because that'll give you the debug information. But it's not necessary for actual builds. So you often include this when debugging. You don't include it when you're in a build file. And yeah, so just because people are going to ask what that file is. So I just really wanted to get that out of the way.
Fair enough.
So now that we've gone through all of this, why did I go through all of that? Well, so we know what DLL is. We know that Unity's over there. But what we can do, here's where it gets interesting. If I go back out to this AP project, so this is AP, and this is the Unity AP. Now, if I open this, Let's see if I can move a few things around here. So this is like I said, the build file. So the CS_proj file literally goes through the incremental steps of saying, define these symbols, add these files, include this stuff, end up with a build, and then build your project. And you can actually make your own CS_proj build files and do all sorts of crazy stuff. You don't need to, but it's like you can actually do some really fun stuff. And this is how you do a lot of automated things. So you talk about continuous integration and how you have this like build and then automatically run your test on build. And then if it fails, do one thing, but if it succeeds, maybe commit it to Git and add this automatic thing. Like a whole series of fun things can be done because this isn't, this is actually its own language. But all we care about is one thing at the bottom. So it says here, to modify your build process, add your task inside one of the targets below it uncommented. So this is a target called after build. So we can say, after build, we want to do something. And so what do we want to do after we build this DLL? Well, we want to copy it. And what do we want to copy? Well, we're going to copy the ap.dll, and we're going to copy it to a destination folder. So the destination folder, so this is the general pattern we're going to go with, but we have to choose where it's from. So it actually starts out inside of the output path. So it's output path, the ap.dll. So that's where we're starting. And we want to go to, and in this case, we're going to go to solution directory. And we're going to go to, let's say, solution directory up1, which will put us here, I think. Let's see what that does for us. Oh, and one thing I like to do, because even if it fails, I still want to copy it. So continue on error, true. You just need that sometimes. We'll ignore that for now. So if I build this, providing I didn't mess up my path. So we've got ap.dll dropped out here away from the actual project because I'm doing this thing. I'm saying when you're finished building this project, take the output DLL that you've built and then copy it over to this directory. And this is, in essence, how I don't have to mess with the two separate projects, one being Unity and one being the external one. Because I say, when I'm finished with whatever I'm doing in my non-Unity project, take the output, dump it in Unity, and let Unity rebuild in the background while I'm still coding without really thinking about it. I don't have to like wait, like my system doesn't freeze while I wait for Unity to recompile. I can still write code while it's adding it to it in the background. So with all of that, we don't want to dump it here. We actually want to go into this one, u.ap, we want to go to assets, and we want to drop it into the plugins folder. So we can say from here, we want to go to u.ap, we want to go to assets, and then we want to go to plugins. And what we can do now is if we just delete that DLL here, save, and rebuild it. Actually, probably should have left the meta file. It doesn't really matter, but I'll leave it just for simplicity. Build, and there's our DLL file. So now the simple act of building this non-Unity project will build and combine and add it to the Unity project. And so any changes I now make over here, if I save this and build it, stuff will happen in the background. This will update. I can now go back over to our Unity project and wallet dot, and I have the max value. So there's no lag time between the two, right? It's for all intents and purposes, it could be the same project. But the difference is I don't need Unity open. I don't need to work with Unity stuff to write code anymore. It's now a completely separate concept, and I can just work with it when I want to. One last step on this before I go any further. So this is a bit simplified. This is literally copy this one file over. But realistically, if your external project uses external DLLs, so that's one other thing too. Because this is just DLLs, people don't really think about this. But if there's external libraries, you can use them in Unity. So a good example of this is I've built Unity projects which access the TV database and like give me lists of TV shows, which I can then do fun stuff with in Unity. Or I can use
like substitute and fluent assertions are a classic example.
Yeah, but that's obviously like for tests. People sometimes disassociate those from like the build version. So I mean, like the stuff that, so like in a built application, I can include something like this. There's a library called REST Sharp. And what REST Sharp does is it like does API calls using REST. Or there's another one. What's it called? There's something else Sharp, which is basically lets you do web scraping. And it basically, if you take a web page, you can run a series of filters to like search the web page and grab information out of it. So it's a great way to like take a website that has a grid of data about COVID-19, for example, and you could scrape it, take the data, and put it into your application. So in the background, your code will like visit a web page, read the file, parse the file, take the data, convert it to a JSON file, include it in your project. You could have all of this magic happening in the background. But my point is that that's like a non-Unity thing. It's just a DLL somebody made that you can use in normal web apps. You could also use it in Unity, because Unity is, at the end of the day, it is an application, but like it's also Unity. It's just an extra layer on top of an application. So all of that being said, sometimes a DLL is not just a DLL. You actually want to include everything in this directory. So it's better than a copy. You can actually do something a little bit more complicated, but it's not too crazy. You create a group of items. And we're going to call this stuff again because it doesn't really matter. And I'm going to say include star.dll. So we're going to include all the DLLs. And we're going to exclude specifically, just in case, Unity engine.dll. So what this means is if I make an external DLL and I reference the Unity engine, I can actually still reference Unity types outside of Unity. So I can write code in my own little DLL outside of Unity here and like talk about vectors and talk about mono behaviors and talk about these components and call coroutines. It's just not going to literally run them through the Unity lifecycle. It's just like building code and testing it.
Yeah.
And then I can say, when you build it, don't like copy a second copy of Unity engine into the Unity engine, because then Unity will freak out and say there's two DLLs here. So that's just saying to exclude it. And the only real difference here is I have to take this. So now it's like output path, all DLLs. And now we use a slightly different syntax and we say, just copy the stuff. So again, don't worry too much about any of this. This is just like the specific syntax of how to use MsBuild. I only even mention it because the point is like, this is how I connect the two things together. Make sure I didn't break anything.
Had some questions come through. Had a question regarding DLLs and compilation based off of dependency. And so basically, if you have one DLL that references another DLL and you edit it, then it's going to have to. Well, if you edit a dependency, then the whole chain's going to have to build. I may have said that incorrectly, but
I can actually demonstrate this quite clearly, right? Yeah. So yes, 100% right. Is if a DLL changes, it'll have to update its references, and that's where you actually can do some clever architecture with it. Yeah. So, for example, I'll do a quick thing here, and I will say, let's see if I can do something. Yeah, so I will say my cool project, and yes, whatever. And then what I could do is I could have a line here where I can say something. So it'll zoom in. There we go. So it'll say this. Thank you. Yeah. So my cool project will say something, but I want it to go to a certain source. So what I can do is I can make an interface, and I don't really want to think about where it goes yet. So I can just call it output, and output can take a message. Now, I'm going to skim this real fast. I do not want to spend time focusing on this, so don't pay attention to what I'm doing yet. I'm just going to highlight the answer to the question. So create that. Output say message. So this is just a really simple set of scripts where what I'm saying is this project takes in some output source and writes to it. Now, to answer your question about external DLLs, this is how I traditionally handle that problem. So I can create something called another class library, and we're going to call it output system, whatever, I don't care, output system. So this is the output system, and I can have this reference the output system, and I'll move the interface into it. So yeah, and this will get to how the DLLs connect now in a second. So if I move this, so for starters, this is going to warn me and say, I don't know what output is anymore. It's not in my project. It exists somewhere else out in the world. So how do I get access to it? Well, if I click here, it'll automatically say reference output system. That's where the output lives. I need to reference the output system to use it. So now, if I go into my dependencies, you'll see over here, where's it? Output system, there we go. So one of the dependencies for this AP project is this other project called output system. An external DLL is referenced by this. So, as rightfully said, any changes to output system forces a refresh of this system. But this is where we're being clever. This project, AP, knows about something called output system, but nothing else, just output system. So I can now make implementations. So I could say, let's just take class library, I can't even spell output. Output system dot console, or we'll say default console. The reason why I don't want to talk about alias namespaces yet, we're not going to get to that. And I'll get collisions of it.
That's a naming convention too that we tend to do, where the default console is just one implementation, so that's how we delineate it. Zoom in.
Yeah. So now we've got this other DLL output console, and I want to make it a implementation of output. And I know this is really like, I'm going through this very fast, so give me a second. If I do this, so output and this is going to implement console write line message. Don't worry, I'm zipping through this. I'm going to stop and I'm going to go back over in a second. Don't worry. I just have to put a bit of plumbing in place first. Where's rename file match?
Ricardo asked about the simple enough, and that's something we don't want to dive into right now. But it's just a plugin that analyzes the code.
Yeah, it's Let's not do that. So I now have this like mini network of things going on. So I've got this thing called AP, and AP is our cool project. Our cool project writes messages to somewhere in the world. It writes messages to it. It doesn't care where, and it's talking to output system to do that. So any changes in the output system will force this AP project, and by proxy this class, to rebuild. So what we want to do is we want to never change this contract. This contract is basically how AP sees the world as far as output goes. So as long as these two stay consistent, these two will never have to rebuild out in the wild. It's perfectly fine. But here's the cool thing. This implements that interface. So what I can do over here is I can add a DLL to the project, which implements this contract, and I can instantiate it and pass it into the other script. So I could actually pass in a console output into this my cool project, even though it has never heard of console output, because it's not referencing console output, it's referencing the same output system. So if that was like a hierarchy, like a tree, both of them talk to the single output system. So this doesn't actually know about this at all. They talk to the same thing. And using a whole series of stuff we're also not going to get into, talking about activators and DLL assembly stuff. The point is, you can make multiple ones of these. So I could actually make a default console. So this prints the console. I could do it with saving. I could say file saver, and I have call save, and I can pass in an object. And I could say file saver.json file, file saver.xml, file saver.web service. And even though the code is changing, as in I'm like adding new stuff, each one of them talks to the file saver contract, and the system, the game itself, only knows about the file saver DLL, none of the others. It can just keep working. And even though I add new ways of saving, it doesn't impact the relationship between those two, between the saver and the actual project that's using the saver. And using other magic systems, you can inject one into the other without actually having to change the contracts, because they don't change. So that's a whole thing that we're not going to get into, because like that's literally like independent deployability and how to make DLL plugins and how to make modular systems where you can actually like deploy plugins to your game or whatever. That's not relevant to anything we're doing. All I'm saying is that the answer to the question of does one depend on the other, yes, but it's not a game changer. It's not going to end your project, because the difference is you can make contract DLLs that serve the purpose of describing how the world looks, and then other things can interact with it. And a final note on this, a common example for this in things like web services is logging. And that's why it's the first thing that came to my mind, because you would often build a web service, and a web service will do all sorts of fun and wacky stuff and download files and log in and accounts, all this stuff. And sometimes it can get very confusing to keep an eye on what's being created, and did people have access, and did someone delete a bunch of data or whatever. So you want to be logging all this stuff. But to be honest, logging is one of those things which is a concern at a business level, which comes down to price. And this is one of those fun things where we've said this before, the one constant in software development is change. And that's why the idea of starting your project and thinking, should I use scriptable objects? Should I use Unity UI? In enterprise, you don't think that way, because if you do, you're designing your software around the fact you're currently sitting on an Azure platform and you're currently using this logging platform. And those things change. Somebody somewhere in a department that's not yours says, hey, I was talking to a vendor at a meetup at this event, whatever, and he's offering us half price. We're switching our entire backend to this system. And you as a programmer are like, okay. And so depending on how you architect your system, that could be a nightmare. You'd have to turn to your boss and say, it's going to take us 4 months. We've like routed that entire system through our code. Or we drew a contract line and say, here is message, go out into the world and do something with that message. We're using a DLL called message sender, and that's all it does. And then we implemented message sender dot log4net, message sender dot rollbar, or we implemented a logging or some other service that goes out to a different client or whatever. And so the job then becomes for us, we don't have to change the old one. We just have to make a new one, message sender dot cool new client, and then we just swap out the one line. This is the one you're using, and bang, system supports it. And you can get into really fun stuff. We do composites. We send to multiple sources and do all sorts of other stuff and conditional stuff, whatever. But all I'm saying to that is your code doesn't change because your dependencies change. And so this is why I constantly kind of argue back when someone says, how do I save my data to XML? Because by definition, that's the wrong question.
Yeah.
You don't care about where you're going. You care of how do I save my data for my game? Well, the silly answer is you call saver.save, abracadabra, something happens. And you implement a method of saving that just happens to conform to that contract, which says when given an object, dump it into a file somewhere. And when you ask for load, read the file and dump it back out again. And you shouldn't care because that's not a concern to your project. That's a concern to whoever's paying the bills or deciding what library we're going to use or whatever else. And you can take this idea to game development. You could say, play audio. What audio platform are you using? I don't know. Okay, we'll just play audio. Well, currently we're going to use master audio because it's better than the default one we're currently using. Cool. Then it comes along. Well, we've grown a bit bigger. We've dedicated higher team now. Let's switch to Fmod. Cool. So we'll swap out the audio player dot master audio to audio player dot Fmod audio. And all of a sudden, the whole system still works. You don't have to go back and change things and rewrite stuff and whatever else. And so it can be hard to think in this way. And when people say, aren't you over engineering? Sometimes, but I will say from experience, change is inevitable. And often what changes is the stuff, the big decisions, not the small ones. The things that change are what database you're going to, whether you're on AWS or whether you're on Azure, whether it's running on a particular platform, whether you're using a particular library or third-party vendor solution. And you do not want your code having to build and change and have to rewrite new lines and swap out different implementations because you decide later to use an asset. And that can be a real nightmare when you're like, I want to switch to this cool new platform that adds spatial audio, but I can't because the system we're currently using is written into every system we've got, and it will take 3 months or 6 months, and we can't afford that in our project. That's a horrible idea that you're actually limiting the coolness of your project because of the design decision you made early on, and that's insane to me.
Yeah, so, that's a good way to put it.
Yeah, so it's a big it's a big topic. Suffice to say, DLLs don't have to be as dependent on each other as it might initially seem. And actually, just a fun fact, now that we've done this, what I can show is, if I build this, see if that worked. What if I included all my stuff right? Anyway, my point is simply that it should build, let's go to that. Sorry, I'm covering so much stuff that I'm losing my own track of what I'm doing.
An interesting question from Raza. Is this a form of dependency inversion? It like supports it. It's like it's a fundamental building block of designing your project and your code in a way that supports dependency inversion, I would say.
Yeah, like you're designing to be able to support those kinds of features, I guess. Dependency inversion is it's more about a flow of control thing, and we're getting into like application boundary line stuff. There's actual terminology around each of these decisions, and I don't want to muddy the waters by saying yes or no to the wrong ones because we'll probably end up covering some of them at certain times.
This is good though, because we want to continue this conversation in further streams. So I think this will go on the list of future topics to get into.
Yeah. So yeah, I mean, I could keep going in terms of like, for example, I wouldn't just have these. I would also create a test project, and I would, write tests for the stuff. I was going to start going through and start making a wallet and then dropping it in, whatever. I kind of think we've covered so much. I don't want to do that.
Yeah, I think we're at a good place here. I see another good question. I think we can sort of wrap it here. And to summarize what we've seen here, the whole point is, when you're given a project, given a problem to solve, or in the case of game development, you're given a game mechanic to implement. In this case, it was our game needs a wallet, or rather not a wallet, a vending machine. And in support of a vending machine, we need the concept of a user and a wallet and all that. The first thought shouldn't be, okay, we know we're using Unity, so what can I use here? Scriptable objects? How's this going to live in the scene? No, the first question is, well, what is a vending machine? What are the rules of a vending machine? And how can I encapsulate those rules in code? And once you do that, you create your contracts for a vending machine. Then you say, okay, well, now that I've got my vending machine implemented, I know that we're going to need to display this thing in Unity. It's my rendering engine. Now let's go ahead and turn up a Unity project, reference our vending machine, which has been vetted and tested, and we know it's good. How are we going to render this? And at that point, you might use scriptable objects, but it's, at that point, it's just a trifling of the details of that implementation.
Mm-hmm. And so it also, like, just in general, is a nice way to kind of reason about things in smaller chunks. Like when I built the vending machine, as I did here, I started with, okay, well, a vending machine has different components. Well, it's going to have a wallet. It's going to have whatever. And so I built a wallet, and I said, okay, the wallet should start empty. You shouldn't be able to go below 0 in it. If I call wallet.canafford15 and my balance is 10, it should be false. And I just reasoned it through, right? Like a lot of people look at this stuff and go, oh, you're adding so much complexity. It's so much stuff. And it's like, it's funny because whenever I hear that, I just think, have you tried it? Because to me, like, I couldn't, just my opinion, but this is so much easier because I can just, like, logically ask myself, what happens when I try to buy something with the wallet and I can't afford it? Well, it should return false. What happens if I take money from the balance? The balance should be less. I can, like, ask myself, write a piece of code to verify that it works, and then just move on. And then when I'm done and I'm finished with all of my, like, reasoning it through, I press the run button, or in this case, like I said, the build, and I can just go in and go, let's just verify. Yeah, it starts empty. It doesn't go below 0. When I take money from the wallet, it subtracts from the balance. If I try to take a negative amount from the wallet, it actually doesn't take anything. I can not only reason about the code easier, I can see that I've hit the notes I wanted to hit, and I then have a system that works. And because it's outside of Unity, like I said, I can just do this without having to rebuild Unity or do anything else. And then when I'm done, I can just, like, display a wallet in Unity. Like, they're genuinely different parts of the equation. And so I personally just don't find this slower or more complicated. I think being able to literally write these lines, balance add 12, check if balance is now added to 12. Like you can't really get much easier than this. It's so hard to say that this adds complexity when literally it's easier to read and is easier to work with. It may be more complex architecturally, but it's not from a working perspective.
It almost in the long run, it decreases the complexity of your project from a human perspective, I'd say, of having to understand what it is. When you come into some of these, like, what's that famous game, Celeste, I think, where they released the player controller class or something like that. Talk about complex. That's so complicated to understand. Now, maybe it wasn't very complicated architecturally. It's literally one file. It's certainly complicated from a flow control perspective and a human perspective, trying to understand what it does. But sure, we've spent a lot of upfront work here. Maybe we've spent an hour and a half explaining this, but realistically, in practice, once you get the understanding of it, maybe it takes you 20 minutes to get to this point. But once you get there, it's very simple, actually, more simple than, I would say, creating a couple mono behaviors and some scriptable objects that, like, hold all your business logic that you can't test them, things like that. So,
and I really can't stress this enough. And, like, if you've watched any other person on YouTube live stream their game development and they make some code and they want to test it, just count from the minute they've finished the last semicolon on the code and press play, and count how long it takes for Unity to build, them to run the project, them to get to the point where they have to do the test, them to interact with the system that they want to check, and they visually have to look at it and go, oh, that looks about right to me. And all of those steps versus I can hit this little checkbox here and go, run, pending, done. Okay, that works. Next.
Or better yet, they're running as you develop. So you don't even have to make that conscious decision. It's just you're just writing code, and eventually one of your tests fails, and you're like, oh, wait, what? It failed? Okay, what'd I do?
Now I will say, just as a caveat to that, there's tons of continuous test runners. The old favorite used to be one called InCrunch, but now the writer has his own built-in one. That's kind of what I use these days. And that's a really powerful feeling, but often you'll have to pay for that. So just keep in mind, you're not likely to get that for free. But basically what it'll do is it's really fun to have a second monitor up with all of these checkboxes. And literally you change a number from 12 to 14 and you get some red error at the bottom of the thing because literally by the act of changing a 2 to a 4, it tells you, oh yeah, but now your wallet value was wrong here because it's gone outside the value of acceptable ranges for the max value. It's like, oh cool, there's none of this like having to hunt down some mysterious bug.
Yes.
Because if you decide to like add a number to the size of the inventory, you'll see immediately if you've broken something. Like literally the act of pressing the button causes your code to tell you that something broke.
Yes,
that
folks,
is like
this is what we
level of
constitute.
power.
This is what we constitute as fun. Opening up a test runner on our second monitor and seeing it fail, which is totally true.
But yeah, like it generally feels like a separate superpower. You can like your code is real time updating to tell you what you're doing, and it just means that your code, everything just feels like it works better, and it adds to a level of security in what you're doing that it's very hard to describe.
Yeah, it's one of my more recent favorite quotes I've been thinking about lately is discipline is freedom. And it truly is. Like if you just have the discipline to set your project up in this way and to really think through your business logic and your classes and your data separately, then there's a lot of freedom in that because you really can start to implement some neat things. Like we mentioned earlier, what if I wanted to have an API, expose the vending machine on an API and make a mobile app where you can log in from work and mess around with your character and stuff like that. There's a freedom in that, I think.
And the other thing too, which is kind of underspoken with this, is if you have two systems, the wallet system I have here, the vending machine system, whatever, the tests are running green for both. If I'm writing a new system that talks to them and a bug happens, there's something that goes wrong. Like for example, I had a bug earlier with this where the UI was nulling out the selection you made when you clicked. It didn't happen in the console version, it happened in the Unity version. And I was like, oh, there's some weird bug here where the selection isn't working. Because I have the tests, because I have the code running, and because I can check and just for double check in the console version, 3/4 of the code written that are interacting with the concept of this null object or this selected object, I don't even have to check because I already know they work. So there's this, it's hard to describe what I mean, but effectively, if you've got 10 moving parts connected together in a system, and you've got some of them tested with unit tests in it, and the tests run, and you can just verify that, you don't actually have to look there for what's causing the bug. So it isn't just faster for building and working in this way, but it means that when you're hunting down a bug, you actually don't have to hunt everywhere. You can actually cut off half the project and say, well, the test proved that that's returning 10. So if this is coming out as 12, it has to be from that point on. And so immediately you can focus in on stuff. And anybody who spent like 3 hours because some object is like rotated the wrong way or some weird number is wrong, and you're like, where is that coming from? I'm reading the console log, and you're like adding 20 prints and going, when does it change? It's like, you don't have to do that. You just have to run it and go, oh, there it is. Like, I know it comes out 10 here, so it must happen in these 3 lines of code. Like, it literally has to. So stuff like that also is just really valuable.
Yeah, for sure. Okay, well, I think this was a good stream, good place to stop here. This is something that we want to continue. I will say that currently, on a personal note, I'm in the middle of moving. My wife and I are moving to a new house, or to a house, our first house. So producing videos has been pretty difficult. I would say impossible, given everything going on.
And so, you're not the only one. I can't even help you with these very often either, because currently my computer's not working properly.
Yeah.
As you can hear, everyone's commenting about the audio. Well, the microphone's different. You're literally hearing a condenser mic rather than the other one I'm normally using.
Yeah.
And then, of course, my internet's not working properly too. So it's probably even stuttering in terms of the packets too. So like, there's a million reasons why currently this is a bit of a janky setup. And even my lights don't work at the back at the moment too. There's a whole lot of stuff wrong at the moment.
Yeah, but all that to say, I think what we're going to try to do is do our best to, in the meantime, do some streams. So I know we've got a stream on Thursday coming up. If everyone can watch that, I think you guys would like that. It's with Ashley from Unity. She's one of the influencers, evangelists, I should say, and the Vivox team. So that'll be cool. But just to say that probably won't be seeing videos for maybe another couple weeks. And so what we're going to try to do is continue these streams. And really just step through some of the things that we do personally when we work on Unity projects. And so
we'll go slower next time. Like, I really want to highlight this was a demonstration of a whole lot of concepts to show like way we do it. This isn't a lesson. So don't worry if this feels like this is insane. We will, if in future stuff, we'll make a point of like taking an idea, like testing your code, or we'll take an idea like, decoupling your DLLs or something, and we'll like expand on those.
Yeah.
That's probably a better idea.
Yeah, definitely. So if you guys could, once this VOD goes up, just leave a comment on that VOD, letting us know what you'd like to see covered next. The logical progression of what we're showing today would be, let's start to do some implementations and actually see that in practice, maybe write some tests and then get that into Unity and show exactly what we mean when we say in practice that the separation of the business logic and the rendering really is empowering. So that'll probably be the next thing we show.
I think what I'd love to do is build an entire system, something like a login dialogue or something, and build it entirely outside of Unity, where it like has validation and stuff, warnings, and pretends to go after a web service and does all of the complicated stuff for logging into your game without even ever opening Unity. And then when we're done, open Unity, start from a blank slate of no code, and show how quick it is to go from empty Unity to like UI with all of that stuff, because the whole point is the logic is done outside of it. That might be a fun one.
And then I think what I've always wanted to do is like that next step, once we get the basic UI and like, okay, now we can show how I can kick it up a notch and do like animations and just other advanced things that would be really hard to do if you wrote your code in a way that was like really coupled to Unity.
Actually, one side note here, because that's a very good point. This is another good reason to do stuff like this. One of the questions is, how do you test inherent randomness? So how do you test something that returns random? So in a more traditional development solution, you would literally run your application and like look at it a few times, see what different things happen, and you'd sort of verify that it works. The way you would test it in terms of this style of approach, if I've got something that the whole point of it is to generate random sizes of values, I will test that it gives me back a number, and you collect a bunch of them in an array, and then you just check that it's got a decent distribution. And you can just, so it doesn't matter what the numbers are, it matters that it returns values and that the numbers return without an apparent like ratio of frequency. And so you can test then that the randoms come out. And then you make a second system that's meant to take in the randoms, like the thing that like scales an object randomly. Well, if this spits out random numbers, and this, when given a 4, makes a thing size 4, and when given a 2, gives a thing size 2, by design, put one to the other, random number equals thing that scales. And there's a whole thing later on about integration testing, but realistically, if something is tested to produce random values successfully, and something is tested to scale when given a number, you can pretty confidently say, when I feed that value into that system, it'll just randomly scale, and reliably so. So you can test those things. You just have to think about where you draw the line for testing.
Yeah, there's a lot of good, I'm sure, concepts that'll spin off of that, like coverage, 100% coverage, things that always seem to arise, like the more difficult things that happen with testing.
Oh yeah, that's actually another, because there's so many things we got about this. Let me just do one last thing here.
All right, it's the last thing,
this is something else I can cover. Over here is called code coverage. Now, that's the test project, so it doesn't matter, and I'm not testing the application. I'm only going to show you the actual project itself. So this is the vending machine project, and what this is it actually shows me how much of my code I've tested to verify that it works. So I have this thing called a wallet, and it's 100% tested. Every single one of those features has proven to have a line of code running a test against it to verify it does what it's supposed to do. Now, have I tested every possible scenario? No, that's a whole different thing. This can lie to you, so don't get too attached to it. But the general idea is that I can verify that I've at least tried to test every line of code in a wallet. And I've tried to test every line of code in a limited capacity wallet. And I have tested everything for the warnings, but that's just a couple of lines, that's fine. But the vending machine, I can look at this and go, oh, I haven't tested what happens when I open it and it's already open. So I can tell this little white line here, I haven't tested what happens when I do that. And that's really powerful on top of everything else to say, let's just double check that I made sure this if statement has been tested and that in this scenario, this event occurs. So this literally tells me I have not tested if I try to open a vending machine and it is already open. So like these are really nice little additions to have, you know?
Dang, that'd be a great video, huh? Coverage. Well, that's
code coverage.
Code coverage, but it's an interesting thing because it's really hard to get to that point when you do write code that's like so coupled to Unity. But yeah, that's definitely a good idea for a video. But anyway, long story short, thank you all for coming here today. We're definitely going to do this again soon, if not next week, then the following. And yeah, catch us on Thursday.
Yeah, and if people are, like they're saying, going to be rewatching this at different things, if you have questions, write them, like literally add comments to the video about things in the video that you're confused about, because that'll tell us what to cover as video. So please, as you go through it and you have different ideas, literally write the questions you have.
Yeah, definitely. And feel free to ask them on Discord as well. But the questions that go on Discord sometimes get lost and don't make it into a video because we just kind of answered in the moment. But usually when we look back at our streams and we're trying to think of what to cover next, it'll be like, let me see what they're commenting about. And that's a good way to guide us. So
feel free to upvote if you like as well. Just saying.
Oh yeah, hey, if you want to hit the like button, who am I to say no, right? Invoke that like button. All right, y'all. We'll have a good day, and we'll catch you in a little bit later, guys.